Let's take a look at number 5 in the set and drift section of your student handbook on the bottom of, or top of page 38. It says at 2038 your position is latitude 41 degrees 9.2 minutes north by 71 degrees 40.6 minutes west. You are on a course of 301 per standard magnetic compass at 8.9 knots. 1 hour later, your position is latitude 41 degrees 11.3 minutes north by 71 degrees 48.6 minutes west. What is this set and the drift? So again, when I start one of these problems, I like to write the words true to remind myself to true up the heading that I'm on. I like to write DR or distance, okay, to remind myself to mark where I should be in the time that I was out there. And I like to write EP for ending position. Okay, so true. I'm on a heading of 301 per standard magnetic compass. So what do I always have to do? If they give me a course in compass, I don't plot in compass, I plot in true. So I use the formula TVMDC. And the 301 is the course in compass, so I put that down at the bottom, which reminds me that I'm going from compass to true. So if I'm doing that, what do I do with errors that are west? I subtract, and if I have errors that are east, I will be adding. So I look for 301. I've got 300, which is 0, so I have no deviation when I'm on a magnetic heading or a compass heading of 301. So I've got 301 for my magnetic. I take the V, which means what? It's variation, which on this chart is 15 degrees west. And if I have a westerly error, I'm subtracting, which gives me 286 degrees. Okay, so my true heading is 286. My DR, where will I be in an hour? Well, if I'm traveling for 8.9 knots for 1 hour, I will be 8.9 miles down the line. Now, obviously, if they give us a time other than 1 hour, we would have to do distance times time to come up with, speed times time to come up with our distance. It's the triangle again. And then I take the ending position, which is 41 degrees, 11.3 north by 71 degrees, 48.6 minutes west. So now that I've got all that information, I can go to the chart. Very first thing to do would be to plot my starting point. Well, I already did that. It's 4109.2. Here's 4110. So 09.2, 0912. Okay, so here it is. And 7140.6. Here's 7140, 40.6. So I brought that down. I marked it on the chart. So now that I've got my starting point, I can draw a line in the direction I'm going, which is 286, true. So I'm going to find 286 with my parallel rule. And I'm going to draw a line from my starting point in that direction. So 286 is, there's 285. Okay, so I'm gonna work like that. Okay, I'm gonna draw a long line from my starting point in the direction I'm going, 286. Okay, 286. And my DR, my distance that I would travel in the time that I was out there. So again, I was going 8.9 miles, so 8.9. My dividers won't open to 8.9, so I'm just going to divide that by 2 and then walk it off. So 4.45 So I'll open these guys up here to 4.45. There's 5. So 4.45. Let's just double check that when I walk it off, I end up at 8.9. I think I did. Yep, I did. So now that I know I'm correct, I'm going to start at my starting point. There's 4.45 and 4.45. Okay, and I'm going to mark that on my chart. So that is my DR. Okay, I'm just going to draw a nice crisp line. Okay, and I'll put a half circle around it to remind myself that it is a DR. That's where I should be given the time that I was out there. So the next step is to plot where I actually ended up. So we're going to take the latitude and longitude. I like to look at the longitude first because it tells me I'm either going to be on this side of the chart, in which case I'm going to use the scale of latitude, or I'm going to be on the other side of the chart and I'll use that scale of latitude. So I always look at that number first, 48.6, which is almost in the middle of the chart, so it doesn't matter much. But I'll go ahead, I'll use this side here. So I've got 48.6 and 11.3. So 11.3. So we've got 10, 11.3. Okay. Almost looks like I've got a mark right there on 11.3. Okay, looks like I do. It may be a mark from an old problem. I wonder if they used that for the same position, but we'll see here in just a second. By 48.6. So 48.6. Again, always start your parallel rule on a line of latitude or a line of longitude. Be careful because there are some lines that are not truly lines of latitude or longitude, like some of these 3-mile marks, okay? Don't be tricked into using one of those by accident. So anyway, I'm looking for 48.6. So 48.6. Guess I should have started that upslope a little bit. So when I swing my dividers, my parallel rule down, I'm still on the scale. So 48.6. So there's 5, 6. Okay, so looks like I am right there. And what was the other number? It was 11.3. Yeah, so it looks like they used the same mark from a previous problem. So it was already there, but that's okay. Okay, so I should be here, but in reality, I'm over here. So what is the current doing? It's actually pushing me. Remember, I'm going from here to there, okay, or I'm going at least in that direction. So the current is really going against me, isn't it? It's pushing me back in the direction. It's essentially slowing me down. I should be on the line. I'm off my line, but not by much, okay? But really, I should have traveled a lot farther given the time I was out there. But in reality, I didn't travel quite as far. So the current is more or less against me. So I'm going to go ahead and I'm going to determine what the direction of that current is. That's quite easy. I simply put my parallel rule between the 2 points. I walk it up to the compass rose, to the hash mark, and I read the number in the direction that the current is setting me. So it's setting me in this direction. Okay, so that's about 98 degrees. So I'm going to write that down, 98 degrees. Okay, and let's see what the speed of the current is. Remember, speed is the distance, meaning the distance between where I should be and where I ended up, divided by the time I was out there. So again, in these problems, I think all these problems are using 1 hour. I know I say we're dumbed it down to 1 hour, but we've made you, not making you think quite as much. So we've got 2.5, okay? So the distance, 2.5, okay? 2.5 divided by the 1 hour that we were out there is 2.5. Okay, so this distance, so the current is 98 degrees at 2.5 knots. This is number 5. So your answer is, do we have a chance, a close one there? There we have 98 degrees at 2.6 knots. So the answer should be B, 98 degrees at 2.6 knots.